Section 4.2 is about congruence in triangles. Let's first define what congruent figures are. Two geometric figures are congruent if they have exactly the same size and shape. So I gave two different figures here, one with a bunch of congruent figures and some that are not congruent. So if you notice, all three of these figures have the same size and the same shape. And here, although all three of these are triangles, they are not the same size, but they are the same shape. So they're therefore not congruent. In two congruent figures, all parts of one figure are congruent to the corresponding parts of the other figure. In congruent polygons, this means that the corresponding sides and corresponding angles are congruent. We'll make sense of this in the next slide with two congruent triangles. When you write a congruent statement for two polygons, always list the corresponding vertices in the same order. So for example, if I start with triangle ABC, notice in our diagram that angle A is the same as angle F, angle B is the same as angle E, and angle C is the same as angle D. So when I write this, if I write it as A, B, C, I have to write it in corresponding order, F, E, D. So I would have to label it just like this. Don't worry about alphabetical order. You have to worry about listing it in corresponding order as the angles are congruent. And if I wanted to list the corresponding angles, I would write them as angle A is congruent to angle F, angle B is congruent to angle E, and angle C is congruent to angle D. Also, if I were to list the corresponding sides, I would have to list that side AB, so segment AB, is congruent to, notice that AB is the same as FE. Since I list A first, I need to list F first. So I would say segment AB is congruent to segment FE. Segment BC corresponds with segment ED. Since I listed B first, I need to list E first. So segment BC is congruent to segment ED. And finally, I have AC down here. If I write it as AC, segment AC corresponds with segment FD. Since I listed the A first and it corresponds with F, I need to list the F first when making my congruent statement. So there is how to write out the congruent statement in corresponding order and how to write out the congruent angles and the congruent sides as far as they are corresponding. Let's look at another example. Number one, notice we have two triangles and we have congruent symbols marking that X is corresponding to N, Z is corresponding to P, and Y is corresponding to M. So let's look at part A, write all of the congruent statements for the triangles. Let's just start off by doing one of them. Going in the order of, let's start with X. So triangle X, Z, Y. Notice if I start at X, I'm going this way. So if I start at N, which corresponds with X, I'm going to go this way. So I have triangle XZY is congruent to triangle NPM, listing them all in corresponding order. I could also start off by using Z as my first letter. So if I said triangle ZYX, since Z corresponds with P and I went in this order, I can start with P and go in that order. So I would say triangle PMN. I could also start with Y. Y corresponds with M. I could start with Y and go this way in order to make my congruent statement. So again, I can start with Y and I'll go in the opposite direction, YZX. Since I started with Y, I'll start with M and go in this order. And so I'd have triangle MPN. So there's lots of different ways. I know it says to write all of the ways, but we could be here all day writing all the different ways and different combinations. But here's just three to start off with. Let's move on to part B, list the corresponding angles, which we've kind of already done when we were writing all the congruent statements for the triangles. So this should be easy. Angle X corresponded with angle N. Angle Z corresponded with angle P. And angle Y corresponded to angle M. And for part C, list the corresponding sides. So again, we want to make sure we write this in corresponding order. So if I name this segment here XY, since I listed the X first and X corresponds with N, I'm going to list it as NM. Let's do the next one. If I do XZ, I'll have to do NP since X and N correspond to each other. So again, XZ congruent to NP. And the last one would be YZ and MP. Since I started with the Y, I'm going to start with the M. So I'd have YZ congruent to MP. Example number 2, in the diagram, ABCD is congruent to FGHK. Since they listed in this order, I can assume that A corresponds with F, B corresponds with G, C corresponds with H, and D corresponds with K. So they started here and went this way. So ABCD, FGHK. So again, we can assume these correspondences based on how they wrote the congruent statement. So part A says find the value of X. So looking at the diagram, I see an X right here. The side GF is 3x minus 6. GF corresponds to BA, which is equal to 9. I also see that angle K is 4x plus 2y, and I know that K corresponds with D. However, if I set 4x plus 2y equal to 44, I don't know what y is in order to solve for x. So I'm going to start off by using this correspondence in order to set up an equation to solve for x. So again, I know that 3x minus 6 is equal to 9 since I know that GF corresponds to BA and they are congruent. So my equation would be 3x minus 6 equals 9. I would add 6 to both sides. So I'd have 3x equals 15. If I divide both sides by 3, 15 divided by 3 is 5. So x equals 5 for part A. Part B says find the value of y. So again, I see a y in this statement right here. I know that angle K is equal to 4x plus 2y. I also know that angle K corresponds to D from my congruent statement here. See, D is at the end and K is at the end. So therefore, I know that 4x plus 2y equals 44. And I'm okay with this time since I know that x is equal to 5. I can take this x equals 5 and substitute it into here and then solve for y. So I would have 4 times 5. Again, I'm using the answer from my previous problem for x in order to solve for y. So 4 times 5 is 20. I would subtract 20 from both sides, so I'd end up with 2y equals 24. Divide both sides by 2, so I end up with y equals 12. Again, I needed to know what x was first before I could solve for y, since my statement, my equation for k, had an x and a y in it. And part C, find the measure of angle F and the measure of angle H. So here is F. I know that F corresponds to A according to my congruent statement. A was first and F is first. If F is here and A is here and A is 80 degrees, that means that F is 80 degrees. So the measure of angle F is 80 degrees. Moving on to angle H. H is up here. I know that H corresponds to angle C because H was third and C was third. So H and C correspond to each other and therefore are congruent. If angle C is 136 degrees, it means angle H is 136 degrees. So the measure of angle H is 136 degrees. Next we have a theorem. It's called Theorem 4.3, Third Angles Theorem. It states if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So if you're looking at the diagram, if you know that angle A is congruent to angle D, angle B is congruent to angle E, then you can automatically assume that angle C and angle F are congruent. So for example, let's say that angle B is 90 degrees. That would mean that angle E is 90 degrees. Let's say that angle A is 30 degrees. That would mean that angle D is 30 degrees. So in our first triangle, that's 120 degrees, and in my second triangle, that's 120 degrees. Remember, there are only 180 degrees in a triangle. So if these add up to 120 and these add up to 120, that leaves us with 60 degrees left over for angle C and angle F. So therefore, angle C and angle F have to be congruent because I only have 60 more degrees left over out of my 180 for them to be able to equal to. So therefore, if I know two angles of one triangle are congruent to two angles of another triangle, the third angles are automatically congruent. Example number 3, find the measure of angle YXW. So notice that our two triangles are on top of each other. We have this triangle here, and then we have this triangle here. I actually find that it's easier to do this problem if we pull the two triangles apart. So that's what I'll do first. So here's my first triangle. So I just drew this one. So let's label it with what we know. We know this is W down here, X up there, and Y over here. I know there's two little half moons and 40 degrees on angle W, and I see one little half moon on Y. And then I'll draw the other one. I'm going to draw this one now. So here we go. This angle is the same as this angle here, so we have another X. And then we have Y, and we have Z. So we have the two little half moons here, and we see one little moon right here with a 35 degrees. So if I have 40 degrees here, and I have two little tick marks right there, I know that Z, which also has two little half moon tick marks, I know that angle Z is 40 degrees as well. I also know that if X is 35 degrees and it has one little half moon tick mark, and this angle over here, Y, has one half moon tick mark, if it's 35 degrees over here, it's 35 degrees over there. So notice I have two triangles where we have two pairs of congruent angles. So therefore, I could use the third angle theorem to know that our remaining two angles also must be congruent. So angle X over here would be congruent to angle Y over here. So remember, I was asked to find the measure of YXW. So YXW is this angle right here, YXW. So therefore, I know that this angle X is congruent to this angle Y. I can find the measure of these two angles by the triangle sum theorem. I know that there's 180 degrees in a triangle. So if I have a 40-degree angle and a 35-degree angle, I can take 180, the total number of degrees in a triangle, minus the 40, minus the 35 to find the measure of our missing angle. 180 minus 40 minus 35 is equal to 105. So therefore, the measure of angle YXW is equal to 105 degrees. And just for clarity's sake, I also know that this angle here would be 105 degrees since these two angles would be congruent by the third angle theorem. Example number 4, we have a proof. We are given that segment SV and RV are congruent, so I will mark that on my diagram. I'm also told that segment TV is congruent to segment WV, so I'll use two tick marks to show that TV is congruent to WV. I also know that segment ST and RW are congruent, so I'll show that with tick marks on my diagram. I also know that angle T is congruent to angle W. And what I want to prove is that triangle STV is congruent to triangle RWV. In order to prove that two triangles are congruent, we need to show that all three sides of one triangle are congruent to all three sides of the other triangle, which we have. We have all three sides congruent to all three sides of each of the triangles that we are supposed to prove are congruent. And we also need to prove that all of the angles are congruent to each other. So far, all I have is that angle T is congruent to angle W. So in some way, I need to show that these two angles are congruent and that these two angles are congruent. And that's how I'm going to set up my proof. Step 1, remember, is to always state your given. So here was all of the given statements, and the reason was they were given. Let's start off with something easy. Do you see how these two angles are across from each other? They are formed by the same two intersecting lines, and these two angles sit across from each other. We know those are vertical angles, and we know from previous chapters that vertical angles are congruent. So my next statement can be that angle RVW is congruent to, and now R corresponds to S, I'm going to write it as SVT, are congruent because of the vertical angles congruence theorem. So there's our statement, angle RVW congruent to angle SVT because of the vertical angles theorem. I'm also going to mark this on my diagram just so I can keep a visual of what I know and what I need to find out. So again, I know that all three sides are congruent, and I know that these two angles are congruent and these two angles are congruent. So my last step is to prove that angle S is congruent to angle R in some way. Thinking back to earlier in this video, we know that if I have two triangles with two pairs of congruent angles, we know that the third angles are congruent. So I can state that angle S is congruent to angle R because of that third angle theorem. So here again, I'm going to mark that on my diagram. I know that angle R is congruent to angle S, and now I have shown that all three sides and all three angles are congruent in each triangle, so I can end my proof with the proof statement. Triangle STV is congruent to triangle RWV, and our reason would be that we know that congruent polygons have all corresponding sides congruent and all corresponding angles congruent, which we have shown. So my reason would be the definition of congruent triangles. My proof is done, so I'll put my two little tick marks to show that. And there you have it. We have proven our first set of triangles congruent. This entire chapter will focus on proving that two triangles are congruent. Again, we started off by proving that all three sides were congruent and all three angles were congruent. Later in the chapter, we'll be able to have some shortcuts where we don't need to prove all 6 pairs of things are congruent. We'll have shortcuts where we only need to prove that 3 or sometimes even 2 things are congruent in order to state that 2 triangles are congruent. Things to look forward to. Our last slide is just some theorems which should be familiar to you. Remember our RST1, 2, 3? Those apply to congruent triangles. So we have the reflexive property for congruent triangles. Basically, it just states that triangle ABC is congruent to itself, triangle ABC. Remember, RST1, 2, 3, there is one statement, one congruent sign. Next, we have the symmetric property of congruent triangles. If we know that triangle ABC is congruent to triangle DEF, then I know, just flip that around, triangle DEF is congruent to triangle ABC. And lastly, we have the transitive property of congruent triangles. If triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, notice that triangle DEF is the linking part here, so that means that triangle ABC would be congruent to triangle JKL, which is stated in the hypothesis of that statement. So remember, RST 1, 2, 3, just like always. That's it for this section. Make sure you write down anything you don't understand so we can cover it in class before we move on, and we'll see you then.